shouldn't make any mistake. I shouldn't, in our way, it will be so hard to have this one. I like this one. Okay, so now, significant figures, as I told you, they are very important to show how accurate we are and to avoid unnecessary steps, measurement. So, the first rule says any non-zero numbers are significant figures. Any non-zero number. Example 17, and let's take this one. 5,631.54. Sorry. So the number of figures in the first case, how many non-zero numbers are there? 2. So the number of significance figure, number of SF, let's make it NSF in short. Number of significant figures in 17? 2. Because according to this rule, any non-zero numbers are significant figures. So we have 1 and 7. What about here? The number of any non-zero number is considered as a significant figure. So in this case, can you tell me the number of significant figures? 1, 2, 3, 4, 5, 6. So in the second one, number of significant figures is equal to 6. Number of significant figures, NSF is. Okay, so for the second one, let's have any zeros in between 2 non-zeros are significant figures. For this, 101, and let's take this one. Okay, so in this case, this number involves zeros. Zeros are sensitive in determining the rules. Please stop. Stop writing. I'll give you time. Please stop writing. When we discuss, I just need your attention. That's all. The first one is clear, right? Mm-hmm. Understood. The second one, any zeros in between 2 non-zero numbers. For example, we have 1 0 in between these 2 numbers, 2 non-zero numbers, which are 1. And because of this, the 0 is considered as a significant. So the number of significant figures will be 1, 2, and 3. So we have number of significant figures in this case, there are 3. What about here? There are zeros in between 2 non-zeros, so they're counted as significant figures. So the number of significant figures? There are 7. Very good. So any zeros before non-zero are not significant figures. So for this, let's have example 0.5, 0.000, 1305. So according to this rule number 3, any zero which comes before non-zero, 0 is coming before 0.5, which is non-zero, cannot be considered as significant figure. So 0.5 has the number of significant figures of 0.5 will be then. Look. 1. Right? Because 0 cannot be counted as significant figure. Because 0 comes before non-zero digit. So the number of significant figure in this case will be 1. If you know this one, you can answer this one, but take care. Center of your all these are not considered. This is considered because It's between, yeah. If you're not confused with this, then I think you passed, most of the test. Okay, so we have 1, 2, 3, 4 zeros, which are not significant because of the fact that they come before a non-zero number. But this 0 between 3 and 5 is counted as significant figure according to rule number 2, which comes before two non-zero numbers. Is that clear? Yeah, so the number of significant figures in this case, 1, 2, 3, 4. Number of significant figures will be 4. So rule number 4 says, any zeros after non-zeros in a number without a decimal point are not significant. So for that, let's take, so example, 500 and let's have 10,000. This is any zeros after non-zero. Look, 5 is non-zero number, and we have two zeros after this 5. And we have how many zeros? 1, 2, 3, 4. Without a decimal point, but it doesn't have any decimal point like this. It doesn't have any decimal point. So these two zeros are not significant. And these 4 zeros are not significant. In that case, the number of significant figures? 1. In this case, the number of significant figures will be 1. But if I put something here, like this, it becomes, all will be counted 1, 2, 3, 4. According to rule number 5, but let's not be confused. So let's go back to the last rule, which says any zero after non-zero in any number with a decimal point are significant figures. Significant is a short way of writing significant figures. So in this case, the difference between rule number 4 and number 5 is the number with a decimal point and a number without a decimal point. Please make sure to underline and remember these facts. So we can take simple examples. Example 500.0, and let's take that one. According to rule number 5, zeros after non-zeros in a number, these 3 zeros are after a number, non-zero, but this number have decimal point. So in that case, we count all the numbers to be a significant figures. So the zeros are counted as significant figures. According to rule number 1, you know that all non-zeros are significant figures. So the number of significant figures will be 1, 2, 3, 4.
Because you just said decimal.
So
has to come after 0.
look, let's rule number 4 and number 5, they're so related, but they have a difference. So if you understand rule number 4, then rule number 5 becomes easy. Rule number 4 says any zeros after non-zero in a number without a decimal point. 500 is a number without a decimal point, right? It has no decimal, but it has 2 zeros after a non-zero number. So in this case, these 2 zeros are not significant. It's a rule that you just need simply to accept. But rule number 5 says, if there is a decimal point, and wait, if there is a decimal point, then these zeros will be accepted as a significant figures. For example,
I understand that, but I'm talking about the next one where there is a 0 after the decimal point and you still count it.
will be counted as significant figure. Just accept it.
So once there's a decimal, whatever comes before or after is counted?
If there is a decimal, actually after, it's counted as. But if the decimal is before, actually, look here, 0.5 is a number, but 0 is before the non-zero number. In that case, even if there is a decimal point, this 0 is not accepted as significant figure.
Yes, I understand that. I'm talking about the last number. Anything after the decimal point is counted.
Yeah. So in this case, how many significant figures? Number of significant figures will be 6. Is that clear? 1, 2, 3, 4, 5, 6. One last miscellany example. Let me have this example, which actually takes maybe most of the rules. 0.010, sorry, 395, 0030. Now look at this number. It has actually some of the rules. So now, how many significant figures are there? Now let's go one by one. It's preferable if we tick each significant one by one. So now, is 0 significant in this case?
No.
No, so let's make it. Is this 0 significant?
No.
Yes, it is.
No.
Yeah, there should be, because it comes before the
decimal points.
Yeah.
It's not.
Is 1 significant?
Yes.
Is this 0 significant?
Yes.
Because it comes between
1 and
2 non-zeros. Accepted. Is 3 significant?
Yes.
Because it's non-zero. 9 is significant.
Yes.
5?
Yes.
0?
Yes. Yes. Wait, what rules was the last one? How's the last one significant?
Okay.
What rules does the last one follow? Oh wait, it's after a decimal. Yeah, but like I don't follow. The last one.
It comes after actually, so it can be counted
Yeah, I
as.
guess you're right, yeah.
So number of significant figures will be?
When just asking, like, what is made for? Like, when is it used in,
Which one?
significance?
Figures? Okay. Actually, this is a set of rules. But this time, you will be asked to know the number of significant figures in a figure. And these figures, actually, there are situations for chemistry, especially. In chemistry, you involve actually most of these figures because there are so many measurements in chemistry. Maybe measurements of mass of maybe particle mass of metals, or maybe mass of any element. Or when you are measuring maybe volume of something, you have some digits actually which are coming. So in that case, we have to use those significant figures. And when you are rounding a number, you have to use a specific decimal point, maybe 3 significant figures or 5 significant figures. If you are asked to do that, then you have to know how to round a number into specific. But at this time, make sure to know how to assign a significant number of significant figures. Okay, so this is one of the things which.
Earlier you took the last 0 because the fifth was stating that after a cake it's okay, right?
Okay, in that case we have, any zeros after 9 zeros in the number. The decimal points are significant. I think so.
Is that the reason?
It happens, yeah. But
Is there a reason we need to put the last 0 because of the fifth rule?
would you pause video?
I don't know.